Alright, let's look at the homework 4.3, problem number 7. Alright, so we want to know the interval increase and decrease. So we take the derivative. So c prime of x is going to be equal to, so product rule, 1/7 x to the negative 6/7 times x plus 8 plus, alright, we have the first guy, and the derivative of that is actually 1. Right? So we're gonna factor out, let's see, so 1/7, I'm gonna factor that out, and also x to the negative 6/7. Right? Alright, what's left is going to be x plus 8, right? Plus, right, if you factor out 1/7, you're going to have 7, and then if you factor out x to the negative 6/7, so you're just going to get x, right? So that's actually 8x plus 8. So we can actually factor, right? We can factor 8 out, so it's 8/7, x to the negative 6/7, right? Then you have 8x, so 8 is factored out, it's x, and plus 1, right? So if you set that equal to 0, you can see that they're critical numbers. This will give us x equals negative 1 is one of the critical numbers, right? But this is undefined when x equals 0, because this is going to be on the denominator. So x equals 0 is also a critical number. Oh, maybe I should write it this way. Since c prime of 0 is undefined, which means that the c0, x equals 0, is also a critical number. Right, so we're going to do a number line. So I'm going to do it up here. So we have a negative 1 and a 0. Then we look at the sign of f prime. Oh, actually, this is a c prime. C prime. Right, try anything less than negative 1, so I'll try negative 2. Right, if you plug in negative 2, so that'll be, let's see, there's a 6th power, so that bottom is going to be positive. So negative 2 plus 1, so that's negative. Right? And we can try anything between negative 1 and 0, so we can try x equals negative 1/2. Right? Then if you do that, negative 1/2 plus 1 is positive, so this is, everything else is positive, so you have a positive sign here. Right, then anything bigger than 0, so I'll try 1. So you can see that this is going to be positive, and that's positive, so it's still positive. Alright, so it's increasing after negative 1 and decreasing before negative 1. Right, so I'm going to just put that in there. Right, increasing after negative 1, so it's going to be starting from negative 1 to infinity. And then it's before, so it's a negative infinity to negative 1. It's decreasing. Right, find the local minimum and the local maximum. Right, so let's do that. And here we have decreasing to increasing. So here we have a local minimum. Right. Here, increasing to increasing, so it's going to be neither. So here, maybe I'll just write that, so it's neither. Alright, so we have a local minimum at negative 1. So you have f of negative 1 would be negative 1 to the 1/7 power is still negative, and negative 1 plus 8 is 7. So it's negative 7 is the local minimum. Right? So let's type in local minimum is negative 7. and the local maximum does not exist. Alright, then we want to find the inflection points. So let's do that. Alright, so we want to take the second derivative, so we have to take C double prime of x. Right, so first derivative is sitting right here. Right, so take the derivative of that. So H7 is just a constant. I'll just put it up here. Right, so derivative of the first guy is negative 6 over 7 x to the negative 13 over 7, and times the next guy, so second guy, x plus 1, plus x to the negative 6 over 7. Then derivative of the second guy is just 1. Alright, so we have that. Alright, then let's factor out. Let's see. I'm going to factor out, let's see, I'm going to factor out this guy right here. So we have x to the negative 13 over 7. Right? So you're going to have, so 8 over 7 is already there. So x to the negative 13 over 7. Right? Then also I'm going to probably factor out the negative 6 over 7. So negative 6 over 7. Right there. So what's left is going to be, so this is factored out and that's factored out. So we have x plus 1 left over. Right? And then you have, since x to the negative 13 over 7 is factored out from here, so it's dividing by this, so you're going to get x, right? So negative 6 over 7 is factored out, so it's going to be negative 7 over 6, right? So we get, so this is going to be negative 48 over 49 x to the negative 13 over 7, and this is going to be 1 minus 1 over 6x. Right? Then we set this guy equal to 0. Alright? Then we have, looks like this is going to be x equals 6. And so that's one of them. Let's see, I'm going to erase this, 6. Alright, and then the second derivative is undefined at 0, so we probably should consider 0 too. Alright, so here. Then we do a number line, so I'm going to actually make some room. Alright, and drawing a number line again. Here's the x, so 0 and the 6. Then we look at the sign of C double prime. Alright, anything less than 0, so I'll try negative 1. Alright, so if you plug in, so this is negative, right? And this is going to be, let's see, negative. Then you have negative 1 here, so you are adding that, so it's going to be positive. So negative, negative, positive, so it's actually positive here. Alright, between 0 and 6, I'll try 1. Right? Then you see that, so this is negative, this is positive, this is going to be 1 minus 1, 6 is positive. So negative, positive, positive, so this is negative here. Right? Then at 6, after 6, so x equals, say, 7 or something like that. So you can see that this is negative, right? This is going to be positive, and this is negative, so you have a positive sign there. Right? So there are inflection points since concavity change here and concavity changes here. So this is the inflection point, and this will be an inflection point. So we need to find the C of 0, which is going to be 0, right? And find C of 6 is 6 to the 1/7, and times 6 plus 8 is 14. All right, so that's that. So you have inflection points. All right, so it's at 0, comma, what was that function? So 0, comma 0, and also 6, comma, all right, 6 to the 1/7 power times how was it 6 plus 8, 14, right? So we have that, or maybe how do I do that, right? Yeah, that should be fine. Yeah, all right, maybe do that. All right, and find the interval where graph is concave upward and downward. So what was that? So it's a concave downward between 0 and 6, right? So let's write that down. Between 0 and 6, and everywhere else. So it's a negative infinity to 0. All right, and union, and 6 to positive infinity. All right, let's check the answer. Submit for testing. All right, I came back, and looks like we got all these guys correctly. All right, that's it. I hope that this was clear.